Hi students, welcome to Maths Point of View. This is our second video on force part A. What we have covered in part A, the complete concepts which are there in force part A, we have covered in part A. That video is available in the description box. Now what we are going to do? In force part A, we are going to solve all the theory questions which is there in your exercise 1A. Numericals, we are going to do it in a separate video so that you should not get any confusion. That video will also be available in the description box. So now without wasting any time, we'll start with the first question. State the condition when upon applying a force, a body has first sub question translational motion, second one rotational motion. So first you need to understand the question. Okay, translational motion or linear motion or rectilinear motion, all the three words has the same meaning. So in the exam they may ask you any word, so you should not get confused, and the answer for all the three words remains same. So first we'll understand the question. See, on applying a force, if you apply a force on a body, okay, when the body has a translatory motion, okay, that is first one. Second one, when the same body, if you apply the force, when will it have a rotational motion? First we'll talk about translation motion. So what do you mean? When it is free to move. When it is free to move. This is the answer for translatory motion. How can you write it in a sentence? On applying a force, okay, when the body is free to move, we can have translation motion. Second one, rotational. Okay, the same body, when the same body is fixed at a point, how can you say that fixed at a point instead of using that word pivoted at a point? Instead of using fixed at a point, pivoted. Pivoted means fixed at a point. Okay, instead of using the fixed, use the keyword. Okay, when a body is pivoted at a point, on applying force, okay, it will have rotational motion. Okay, sometimes they may ask you this question also. A body is pivoted at a point, and why it doesn't have a translational motion? Why? Because it is not free to move. So these kind of questions you can easily expect. So if you understand the concept, answering these kind of questions is very easy. State whether the moment of force is a scalar quantity or a vector quantity. Very simple. Listen, first you need to know the condition. So how can we say it is a scalar or a vector quantity? If a physical quantity, any physical quantity, what do you mean by physical quantity? Don't worry, the words, okay, the work done and current, all those things, potential difference, any words which we are using in physics, the words means it should have some formula, all those things, those are called physical quantities. Any physical quantities which has only magnitude but no direction, without direction, that is called as scalar quantity. What do you mean by magnitude? Magnitude you already know. Magnitude is nothing but the numbers, 50 kg, 500 ml, 200 grams, all these numbers. You don't worry about the units, you just worry about the numbers. Those numbers are called magnitude. So how can we say whether it is a scalar quantity or a vector quantity? If it has magnitude but no direction, it is a scalar quantity. If it is to be a vector quantity, it should have magnitude and also the direction. So now here moment of force, how can we say moment of force is a vector quantity or a scalar quantity? See, what do you mean by moment of force? Rotational motion, correct? If you apply a force at a pivoted point, it will rotate instead of moving in one direction. So if it is rotating, it should have only two directions, one anti-clockwise or clockwise. That can be easily assumed with the direction of force, correct? So moment of force is a vector quantity. Why? It has both. See, all those explanations for your understanding. What you have to write in the exam. Moment of force is a vector quantity. Why? Because it has both magnitude and also direction. If you write this is for 2 mark question. Okay, why it is a vector quantity? Why? It has both magnitude and direction. If it is a scalar quantity, it has only magnitude, no direction. Write an expression for moment of force. Listen, that is nothing but a formula, correct, that we have discussed. Moment of force is equal to F into D, but in the exam don't write F into D, write the full form. How can you write it? Moment of force is equal to magnitude of force multiplication symbol and perpendicular distance from the axis of rotation. So this is how you have to write in the exam. State the one way to reduce the moment of force. See, this is a very easiest question, correct? Why? Because if you know the formula, you can easily answer. See, if they are asking whether to reduce or increase, if you know the formula, aram se you can answer. How can we answer? See, moment of force formula is force into displacement, correct? Perpendicular distance. Now listen, so if you want to increase the moment of force, what you have to do? You should increase the force, magnitude of force. If you want to increase the moment of force, what you have to do? You have to increase the perpendicular distance. Now they are asking to reduce it. So reduce the magnitude of force. On reducing the magnitude of force, moment of force will reduce. Or you can also write, on reducing the perpendicular distance from the axis of rotation, you can reduce the moment of force. You can write any one of these answers. State one way to obtain the greater moment of force. That is what we discussed in 8th question, but it is in opposite way. See, in 8th question, they were asking to reduce the moment of force. Here, they are asking to obtain a greater moment. See, to reduce, you have to decrease any one of these, correct? If you decrease both also, moment of force will also reduce. You can write any one. To increase, you have to increase magnitude of force or perpendicular distance from the axis of rotation. If you increase any one, moment of force will also increases. Define moment of force and its SI unit. See, defining any term, it is very easy when you know the formula. So what is the formula for moment of force? Is equal to force into displacement, correct? This is the formula for moment of force, which we have learnt in part A, that is available in description box. Okay, how can we define moment of force using the formula? See, moment of force and moment of couple as the same formula. You can define both the things in this way. See, moment of force can be defined as product of, what do you mean by product? Multiplication, right? Product of magnitude of force and the perpendicular distance from the axis of rotation. So this is nothing but moment of force. See how easy it is. If you know the formula, you can aram se define it. Now they are asking what is the SI unit. SI unit of moment of force. See, what is the unit of force? Newton, correct? What is the SI unit of distance, perpendicular distance? Meter. So SI unit of moment of force is Newton meter. They may ask you in a different way, what is the CGS unit of moment of force? See, what is the CGS unit of Newton? Dyne. And what is the CGS unit of meter? That is centimeter. This is SI unit of moment of force. This is CGS unit of moment of force. You can expect anything in the exam, and also they may expect you to write the relation between Newton meter and Dyne centimeter, or SI unit and CGS unit of moment of force. All these things we have discussed in part A. State the factors affecting moment of force. So if you want to answer this question, you should know the formula. See, moment of force is equal to force into perpendicular distance, correct? This is the formula for moment of force. Now this is enough to answer this question. Which are the factors affecting moment of force? One, the magnitude of force. Okay, the second one, perpendicular distance from the axis of rotation. Perpendicular distance from the axis of rotation. These two are the points you have to write. When does a body rotate? State one condition to change the direction of rotation with a suitable example. This question is for 2 marks. Very simple question. Listen, how can you make a body rotate instead of moving in one direction? The very simple answer is, see, assume a body, okay, circular body, okay, instead of moving in one direction on applying a force, it should rotate. So for rotation, what should we have? We should have the pivoted point. So how can we answer? See, all these explanation is very easy for me, but how can you write the answer in the exam? That is also very much important. When a force is applied on a body which is pivoted, see, this is how you have to write. When a force is applied on a body which is pivoted at an appropriate point. See, you can apply force in any direction, correct? You can apply the force directly like this, or you can apply force directly like this, or anywhere like this, correct? So it is very important to write appropriate point. What do you mean by that? See, if you apply a force in this direction, okay, do you think this body is going to rotate? Yes. what if you are going to apply a force in this direction? Okay, assume this is a 3D wheel. If you apply a force on the center point, okay, here pivoted point, do you think it is going to rotate? No. So it is very important to mention appropriate point. So what is the final answer? When a force is applied on a body which is pivoted at a appropriate point, the body will rotate. Okay, now they are asking one more thing. State the condition to change the direction of rotation. Listen, very simple. If you are applying a force in this direction, this body will move in anti-clockwise direction, correct? This body will move in anti-clockwise direction. Now assume the same body and a pivoted point. Now if you apply the force in this direction, okay, if you apply a force in this direction, what happens? It will rotate in this direction. The point where you are applying a force is also important. So if you change the direction of application of force, the direction of rotation will also changes. This is with an example. What do you understand by clockwise and anti-clockwise moment of force, and when it is taken as positive? Very simple question. Listen. Okay, first I'll explain with a diagram and I will tell you what to write in the exam. Listen. So if you apply a force in this direction, what happens? It will rotate in anti-clockwise direction. This is nothing but anti-clockwise movement. If you apply a force and the body rotates in a clockwise direction, that is nothing but clockwise moment of force. That's it. So how can we write? On applying a force on a pivoted body, if the body rotates in clockwise movements, then it is called as clockwise moment of force. Okay, next, on applying a force, if a body moves in anti-clockwise direction, then it is called as anti-clockwise moment of force. Anti-clockwise movement is always taken as positive. Clockwise movements are always taken as negative. Anti-clockwise positive, clockwise negative. That's it. Why it is easier to open a door? By applying a force on the free end of it. Okay, what do you mean by that? First, assume there is a door. Okay, there is a door. At the end of this door, which is connected to a wall, see, there will be two ends of a door. One which is connected to a wall and the other end is called free end. So this wall, you can see three blocks, right? This is called hinge. This is called hinge. This is very much important when it comes to door. Okay, so the question is, why it is easy to open a door on applying a force at the free end of the door. Okay, listen. Assume this handle, okay, the handle which we use to open or close the door is near to this hinge. What will be the perpendicular distance? See, the perpendicular distance is nothing but from here to this end. Okay, assume the handle is here. Now what is the perpendicular distance? It is very less. So according to the formula, if the perpendicular distance is very less, the moment of force is also less. So what do you mean by this statement? If the distance is near to the hinge, if the distance between the hinge and the handle is very less, then it requires more force to open. That is why it is easy to open a door when you are applying the force on the free end. So what happens here? At the free end, from the hinge, okay, the perpendicular distance is maximum. So if the perpendicular distance is maximum, that means we need to apply less force. The stone of the hand floor grinder is provided with a handle near the rim. So this is the question. They are asking the reason. See, it is very simple. Listen. This is, what is this? This is pivoted point. Pivoted point means at this point it is fixed to one more stone. So because of pivoted point, the whole part is rotated. Correct? This is pivoted point. Now near the rim there is a handle. Why we have to have the handle? It is very simple. Listen. Assume this handle is somewhere here. Somewhere here. Okay. Do you think it is easy to rotate or hard to rotate? It is hard to rotate. Why? Because the perpendicular distance. See, here you are going to apply a force. Correct. Here you are going to apply a force. Now, what is the perpendicular distance? This is an example for moment of force. Correct. Moment of force is nothing but both force and perpendicular distance. So here you are going to apply a force. What is the perpendicular distance? How can we calculate the perpendicular distance? Always with the pivoted point, that is fixed point. The perpendicular distance between the pivoted point and the handle is very less, so you need to apply more force to rotate. So that is why we have provided, okay, the handle near to the rim. Near to the rim means the corner. So now see the perpendicular distance. Okay, now the perpendicular distance is maximum, correct, at the near to the rim. Okay, near to the rim. So it is easy to rotate the stone grinder. It is easy to rotate a steering wheel with a larger diameter than the smaller diameter. Now we need to understand the question properly. Listen, assume there are two steering wheels, A and B. A has a smaller diameter, B has a bigger diameter, larger diameter. The question is, if you have a larger diameter, it is easy to rotate compared to the smaller diameter steering wheel. So how can we answer this one? So this is an example for rotation, right? Whenever there is a rotation, we are talking about moment of force. So whenever there is a rotation, we are talking about moment of force. Moment of force is equal to F into D, correct? F into D. Here we are talking about the diameter, so don't talk about the force. So it is related to diameter, so we need to talk about the perpendicular distance. If they are talking about Newton, okay, force, we need to talk about force. They are talking about the diameter. Diameter is nothing but length, correct? Length related problem. So we need to talk about the perpendicular distance. So if the perpendicular distance between the pivoted point means the point where it is fixed, and the end of the rim, okay, is very big compared to this one, correct? Here the perpendicular distance between the pivoted point and the end of the rim is very small. That is why it is easier to rotate the steering wheel with a larger diameter. Now we'll talk about the 13th question. Okay, assume a spanner with a long hand. Why we need to have a long hand? That is the question. Long hand means it has more perpendicular distance. More the perpendicular distance, more will be the moment of force. But in the exam, they will not be expecting this as an answer. So what you have to write? First you need to understand the concept. If the perpendicular distance is more, moment of force is also more. What do you mean by that? If the moment of force is more, that means you need to apply less force to rotate the object. So more the perpendicular distance, more will be the moment of force. That is nothing but it requires less amount of force to rotate an object. The same answers goes for this question. So the jack screw has a long hand. So if it has a long hand, it requires very less force to use it or to lift an object. That's it. It is for 2 marks and it is a very easiest question, but if you understand the question, it will be very simple. Okay, listen. There is a heavy roller and with a axle. Axle is different, pivoted point is different. Axle means a point, a center point. Pivot point is the point where it is fixed to something. So here it has given as axle, that means it is not fixed anywhere. Okay, listen. Now the question is, this heavy roller has to move to the pavement X and Y. Pavement means the path. Okay, don't worry about it. The path, this has to move somewhere here on XY. Now we'll talk about point of application and direction of force. Do you think those two are different? Yes, those two are different. How? Listen, what do you mean by point of application? The point at which, exactly at point at which, where you are going to apply force. Okay, I am going to apply a force in here. Okay, this is the point of application for me. And the direction of force. Okay, how they are differ? Listen, this is point of application. Here I can apply the force in different direction. I can apply a force in this direction, and I can apply a force in this direction, and I can apply a force in this direction. Which direction of force will make this heavy roller to move on this pavement X and Y? So in which direction? If you apply a force in this direction, what happens? It will start rotating in clockwise direction, correct? Now do you think this is going to move this one up on pavement X and Y? No. So the point of application is okay, the direction of force is important. You need to apply a force in this direction, not in this direction. Okay, in this direction if you move here, okay, there will be a greater force, so it will rotate this object, roller, heavy roller on this pavement X and Y. Make sure this arrow mark is in straight line. Now if pivoted at O, will it go up? This is a simple question. Listen, I told you axial is different, pivoted is different. Axial is a point, center point. Okay, pivoted is nothing but this point is fixed. Okay, at O it is fixed, so it cannot go up, correct? If it is fixed, it cannot move from one point to another point, but it can rotate. The question is, if pivoted at O, if there is a pivot point, will it go up? Will it go up? No, it will not go up, it will rotate. That depends upon the direction of force. If pivoted at O, will it go up? You should write the precise answer. Don't explain many things in physics, just write the precise answer. If pivoted means it will not go up, it will rotate. If pivoted at O, will it go up? No, it will not go up. That should be your answer. That's it. Define moment of couple and its SI unit. Listen, I told you moment of couple is nothing but moment of force only, but the way of explaining is different. Moment of couple is equal to force into D. So using this formula, how we can define it? Moment of couple is equal to product of either the externally applied force or reactional force to the perpendicular distance on the line of action is called moment of couple. So what is the SI unit? See, moment of couple and moment of force as the same SI unit. SI unit is same, that is Newton meter. CGS unit will be dyne centimeter. That's it. See, this question was asked one time for 2 marks. The meaning of equilibrium, this we have explained in part A, correct? While teaching about the equilibrium, we have taught the meaning also, so we don't have to waste the time in this video. This is the easiest question, but for this you should know the condition. What they are asking, condition for static equilibrium and dynamic equilibrium. Very simple. See, if a body remains at rest, not moving, remains at rest even under the influence of forces, this is called as static equilibrium. Example, a book lying on a table. So even though there are two forces, one force is due to the weight of the book and second force is due to the table on the book. So there are two forces, but still the body, the object is not moving. Next, dynamic equilibrium. If an object remains in the same state of motion, whether it may be translation or rotational, okay, even under the influence of forces, this is an example for dynamic equilibrium. Example, raindrop reaching the earth. So due to its weight, it is going in downward direction, and due to the buoyant force of air that is in opposite direction, that is not resisting the raindrop to reach the earth. So even under the influence of forces, the raindrop is reaching the earth in the same state of motion. Example, don't explain the examples, just write raindrop reaching the earth. State the two conditions for equilibrium. Listen, don't worry about the lengthy question, just understand the inner meaning of it. State the conditions for equilibrium. First condition, the resultant force of all the forces acting on a body should be 0. This is the first condition. Second one, the resultant moment, not the force, the resultant moment of all the forces acting on a body around the point of rotation should be 0. So if you understand it, it is very easy. The first condition we are talking about the static equilibrium. The second condition we are talking about dynamic equilibrium. If you understand it, very simple to answer any kind of questions based on this one. State the principle of moments, name the device, work on this principle. Very simple, listen. The algebraic sum of moment of forces acting on a body around the axis of rotation is 0. Okay, is 0. If you want to write this one, that is good. If you don't want to write this lengthy sentence, you can write, listen, principle of moments are nothing but clockwise movements is equal to anti-clockwise movements. You can also write this as an definition. Though, how can we write it? The principle of movement states that clockwise movements, the algebraic sum of clockwise moments are equal to the sum of anti-clockwise moments. Name the device which works on this principle, beam balance. So the device which is used by the vegetable vendors, the beam balance to weigh the vegetables, that is an example for principle of moments. Listen, this is a very simplest question to get 4 marks within 1 minute. Say for explanation it will take more than 1 minute. But to solve this question it requires only 1 minute if you know the logic. See, I am going to teach all the logics. Listen, see, there are 3 forces. All the 3 forces have same magnitude. Same magnitude means the force of A, okay, is 4 Newton, force of B is 4 Newton, force of C is 4 Newton. Next, so they have given different perpendicular distance. So they have given force and also perpendicular distance. What we can calculate? Moment of force. That is what they are asking. Listen. So first we will calculate least moment of force and greater moment of force. So to find all these things, we'll find moment of force for all the 3 different forces, then we'll get the answer. Listen, moment of force of A is equal to, it is force into distance, correct? What is the force? Force is 4 Newton and distance, what is the distance of A? 0.9 meter, 0.9 meter. See, if they have given in centimeter, you have to convert into meter, then only you will get the proper answer. Anyhow, if you have the numbers, you will get the answer, but whether it is correct or not, that is important. So 4 9s are 36, so that is 3.6 Newton meter. Now moment of force of B is the same formula, force into distance. Now what is the force? Force is 4 Newton for all the 3 forces. Next, what is the perpendicular distance for B? 0.8, 0.8, then answer will be 3.2 Newton meter, correct? Next, moment of force of C is equal to 4 into, what is the distance? 0.6, 4 6 are 24, that is 2.4 Newton meter. Now we have all the values. Now we can easily answer those questions. Listen, least moment of force. Which has the least moment of force? It is 3.6, 3.2, 2.4. So C as the, okay, least moment of force. Next, greater moment of force. Which has the greater moment of force? A, correct? A has the greater moment of force. Now the third question, which of the forces will produce clockwise moments and anti-clockwise moments? So based on these direction, we cannot assume the clockwise moment and anti-clockwise moment. Why? Why? Because these are the direction of forces. These are not the direction of rotation. So after applying force only, it is going to rotate. So these are not the force. A, B, C are not the direction of rotation. These are the direction of forces. So how can we find clockwise and anti-clockwise moment? Very simple. Assume there is a circle. Okay. Assume this as a circle. If you apply a direction, see A. If you minimize this A, this is nothing but in this direction, correct? This is A. If you apply a force in this direction, this will rotate in clockwise direction. So clockwise moments will be produced by A. Okay, we'll do the same thing for B and C also. Now for the same circle, minimize this direction of force B. If you apply a force in this direction, what happens? Whether it is going to do a clockwise moment or anti-clockwise moment? Clockwise. So B is also producing clockwise moments. Now we'll see with C. Okay. Minimize the direction of force of C in this direction. C in this direction. If you apply a force in this direction, the rotation of this object will be anti-clockwise. See, if you apply in this direction, this is going to rotate in this way, correct? This is nothing but anti-clockwise. So which force is producing anti-clockwise? That is nothing but C. Now we'll talk about resultant torque at O. For all these things, we should have all the moment of forces, correct? That is what we have calculated. I have written all the values here for the calculation. Listen, how can we solve that? First, you need to understand clockwise moments are always taken as negative. Anti-clockwise moments are always taken as positive. That is important. So what do you mean by resultant of force? Addition of everything will give you the final answer. But here the signs, negative or positive, is very much important. So first, moment of A plus moment of B plus moment of C will give you the final answer. Correct. So moment of A and B, see A and B, here it is taken as negative. Why? It is clockwise moment. So minus 3.6 minus 3.2 plus 2.4. You will get the answer. Listen, it is very important to know why we are adding negative signs. Listen, A and B are clockwise movements. That is why we have to take it as negative. Minus 3.6 and minus 3.2 is nothing but minus 6.8. Correct? Plus 2.4. That is nothing but 4.4. See, minus 4.4 is the resultant torque at O. See how simple is it? Do you feel any complications in the numericals? No, it is very simple. So if you understand the logic, numericals are very simple. I think this is only numerical we have in theory part. We can solve all the numericals question by question in another video. That video will be available in the description box as 1A numericals. This will be 1A theory, correct? And the numerical part will be 1A numericals. Very simple question, but it is logical question. Listen, there is a body, okay? There are two forces acting on it. Okay, we need to state the effect of forces on it, but they have given one condition: those two forces are equal in magnitude. How can you say they are equal in magnitude? That is not mentioned in the question, but they have given the magnitude of forces of each force is F. F means for both the forces it is F. If F1, force 1 is 10 Newton, force 2 will also be 10 Newton. But one more condition, they are opposite in direction. This is very important point. Okay, I'll tell you why it is important. First we'll talk about A. What is the question A? Two forces are acting on a same point, Assume you can take any point, you can take this point, any point. I'll take this point, okay? Now assume this is the point of action of force 1. Then force 2 action will be in opposite direction. Why? Because in the question they have mentioned they are equal in magnitude but opposite in direction. Okay, opposite in direction. If you take the point here, again F1 will be here, F2 will be here. Okay, now we have to tell them what is the effect of this force. So effect of this force will be resultant force. Resultant force will be F1 minus F2 is equal to 0. Why F1 minus F2? Why not addition? If they are in same direction, then we will add it. If they are in opposite in direction, we have to subtract it. We know F1 value is equal to F2 value. That is why F1 minus F2 is equal to 0. The resultant force will be 0. So there will be no effect on the body due to subquestion A. Okay, now we will talk about subquestion B. Okay, the two forces are acting on a body in two different points. What will be the effect of force on this body? Okay, listen. See, even though it is a different point or same point, the answer remains same. Why? Because the two forces are opposite in direction. Okay, assume you can take any point. Okay, you can take this direction or any direction. Okay, assume this as F1. Okay, opposite to this will be this point, correct? Why opposite? Because these two are in opposite in direction they have given. So F1, F2, see, the force is acting in this direction, this force is acting in this direction, and both the forces are equal in magnitude. So resultant force will be F1 minus F2. Why again minus? Why? Because opposite in direction. Both the values are equal, again 0. So what you have to write in the exam, the resultant force is equal to F1 minus F2 is equal to 0. That means moment of force is equal to 0. If F1 minus F2 is 0, moment of force will be also be 0. That shows there will be no effect on this body for subquestion A. The same thing you have to write for sub question B. Even though there are two different points, the forces are in opposite direction. That is why F1 minus F2, that is 0. The resultant force is 0. If the resultant force is 0, moment of force is also 0. If the moment of force is 0, then there will be no effect on the body. Draw any diagram to show two forces acting on a body which produces rotation, and we have to tell them which type of rotation is this, and we have to use the letter O. So what is the meaning of this question? You have to take an object and two forces you have to include in any direction, but it should provide a rotation. That's it. Which type of rotation, we were going to write it at the end. Listen. Assume there is an object. Okay. Assume there is an object. To have a rotation, we should have a pivot point. In the previous question, there was no pivot point. That means question number 17. That is why we did not have any rotation or any effect. Here, for rotation, we should have a pivot point, and that should be written as O, which is given in the question. Okay. Now, to make it rotate, only one force is enough. But in the question, they have told we have to use two forces. So, assume I am applying a force in this direction. Okay, that means in this direction. Okay, if I apply the force in same direction, two forces they have given, but they have not mentioned two different forces. Correct? Two different forces. That means two different magnitude forces. So we have to take two forces with the same magnitude. If I apply one more force in the same direction, do you think this is going to rotate? No. So if the force 1, okay, F1 is in this direction, upward direction, F2 should be in downward direction, so that we can get a rotation. This is F2. Okay, so now we can have a rotation. So this is the diagram they are asking. Okay, now which type of rotation they are asking? See, if you apply a force in this direction and this direction, this is going to rotate in this way. Correct? This way. Which type of rotation is this? This is a clockwise rotation. Clockwise rotation. This is enough. Okay, you can draw the same thing in different way. Okay, there is an object at a pivot point O. Now here I am going to apply force F1, and here I am going to apply force F2. Okay, if you apply a force in this direction, okay, then what will be the type of rotation? This is anti-clockwise rotation or anti-clockwise movement. So clockwise is always taken as negative and anti-clockwise is always taken as positive. Okay, so this negative positive they are not asking, you should keep this one in mind. What do you understand by couple? State the effect on it and a few examples for it. Listen, very simple. How do you define a couple? What do you mean by couple? See, whenever there is a rotation, there will be two forces, correct? Two forces. One which we are applying, that is called as externally applied force. Then another one will be reactional force. So how can we answer this question in the exam? Not like this, in the exam. Two equal and opposite parallel forces which are not acting on a same line of action, is called couple. Okay, now what is the effect of couple? Effect of couple will be nothing but it will rotate the object. Few examples. Key inside a lock. See, we use key to rotate the object, correct? So key inside an object are opening or closing a water cap. Next, few more examples. Steering wheel. That's it. So answer are very simple. If you have understood the concept, you can answer this one. This is direct question. Why do you want to miss this one? It is based on an experiment. Experiment based questions will not be asked in ICSE exams. So don't worry about it. All the numericals will be in one video. That video will be available in the description box. Thank you.